Hi, this is Algebra 1 with Miss Andrea. Welcome back. I'm excited to have you again. We're in to Unit 3b, module, I believe it's module 6. And we are moving on. It's page 5. And so in this lesson, what we're going to get into is something you already were practicing in a previous lesson. We went over it. Um, is converting between the vertex form and the standard form, right? And so let's just real quick, let's remember what each of these forms are. So we've got vertex form, and then we'll write standard form over here. Now, standard, again, both of these you should have written down in your notes or possibly even memorized. A standard form you should probably have memorized by now, but it's ax squared plus bx plus c. Now, remember, this is just the expression. You can make an equation out of it by setting it equal to something. You can set it equal to 0 if you're going to solve. You can set it equal to y if you need it to be an equation, or to f of x if you need it to be a function, okay? Now, vertex form is a times x minus h squared plus k. Again, it's an expression, and you can set it equal to the same things if you want to make it into an equation. All right, each of these tell us different information. So C, remember, is the y value in the y-intercept. So when you have an ordered pair for the y-intercept, you're going to have 0 something, and whatever that something is found in the C location. That's your y-intercept, right? And then we use A, B, and C in the quadratic formula in order to solve some of the quadratic equations. So that's what standard form is used for most of the time. It's very useful. Vertex form is also very useful, but for different reasons. The number one thing is we easily can identify the vertex, which is HK. That's why it's called vertex form, right? HK. And if you notice, we're always taking the opposite of whatever we see in our formula because of that minus sign there for H. So the opposite of what we see is what H is. And then remember, H stands for horizontal, so that's our horizontal change, or right and left shifting. And then K is our vertical change, so that's your up and down changing. And then A has kind of two functions to it. Not only does it stretch or compress, but it also tells us whether or not the graph is going to be reflected over the x-axis. So these are our two forms, vertex form and standard form. If you don't have them written down, write them down now. All right, so how do we get from vertex to standard form? Well, looking at this, it looks like the first thing we should do, well, let's say this. I previously, in a previous video, showed you how to transition from standard to vertex, but it didn't actually show you vertex to standard. I just said, well, just do the math, just expand it. And so that's what we're going to do. We're going to expand it. And it does look like you would start with the -2 because that's what you're taught, right? You're supposed to distribute. If you see that, do it. Don't forget, do it first, right? Well, in this case, we can't do that first because of PEMDAS, right? PEMDAS, distribution. If we were to take this 2 and distribute it in there, what are we doing? We're multiplying this -2 times each term within the parentheses. Well, multiplication is down here. We have this exponent right here, and you see the exponents come first. So we have to do the exponents first before we can do the distribution. So you can't miss that itty bitty little exponent that you see way after you see this -2. So you got to look at the whole problem before you decide where to start. So let's just look at that. I'm going to change colors to do my exponent, my squaring. And remember, this is going to be x minus 1 times x minus 1. That's what a square is whatever you're squaring times itself. Now, there's two ways that you can do this. You can do the FOIL method if you prefer. I prefer doing it this way. I don't know what this is called, but I like this because it works for every type of problem that you get. So x times x is x squared, x times -1 is -x, -1 times x is negative x. -1 times -1 is positive, oops, +1, not +2. Let's undo that. +1. So then you have x squared, -2x, and +1. Now, if you notice, when you have a perfect square, in other words, you have an expression that's being squared, all you have to do is square the first term, and that's your first term. You square the last term, -1 times -1 is +1. Now, to get this middle term here, what you have to do is you multiply the first term times the second term, x times -1, and then you multiply it by 2. So x times -1 is -x, times 2 is -2x, okay? So that's just a little way to check your work and make sure you've gotten the problem correct. All right, so let's continue on. So that was just this part right here, just the squaring. So now we need to plug it back into the problem. We're going to take the squaring that we did and put it in some parentheses right where it was in the problem before. So we've got -2 times x squared minus 2x plus 1, close parentheses, and then we have the +7. Okay, so now is when we're going to distribute. If you're going down PEMDAS, after exponents, you do the multiplication. Now you may be asking, why didn't we do the parentheses? Because there are certainly some parentheses there. Well, you can't do x minus 1. X is an unknown, so we can't do that. So that's why we skip that step. And we still have our x in our problem. So -2 times x squared is -2x squared. -2 times -2x is +4x. -2 times +1 is -2, and then +7. And we need to combine these like terms, these constants, and we get f of x is -2x squared plus 4x plus 7. And that is our final answer. That is this equation moved from vertex form to standard form. All right, so to move from standard to vertex, hopefully y'all remember what we did. We had two different ways. One way is completing the square. And remember, when we complete the square, we start by writing our equation. Get rid of that. X squared minus 6x, I'm going to leave it blank here, equals, and I'm going to move this -9 to the other side. Pretend to have an equals over here instead of over here. I'm going to move it to that side. So if it switches sides, it switches signs. So it's going to become a +9. Now to figure out what's going to go in the blank here, I'm going to go ahead and half this. Half of -6 is -3. -3. And then I square it. And I'm going to add what I squared. -3 times -3 is +9 to both sides. So I'm going to have here x squared minus 6x plus 9 equals 18. Okay, now I can complete my square here. X minus 3 squared. And then I'm going to move my 18 back to the original side, -18. And then I can put y equals x minus 3 squared minus 18. And this is in vertex form. Okay, so let's try this. Y equals x squared minus 6x minus 9. Doing it the other way. And remember what we did for the second way was to do -b over 2a. And that gave us the x in the vertex. This is an a, not a 9. And that gave us the x in the vertex. So -b, the opposite of b. So the opposite of b would be +6 all over 2 times what? Times 1, because a is 1. b is -6, a was 1. Okay, so the opposite of b over 2 times 1, that's 6 divided by 2, which is 3. So now that we know the vertex of the x, we have to think about, okay, well, what's our vertex form? Our vertex form is y equals a In this case, a is 1. We already know that. So I'm going to go ahead and erase that because we don't need to have a 1 times something, right? X minus h squared plus k. And remember, the h is the xv and the k is the yv, or the x in the vertex and the y in the vertex. So we just found out what xv was. So we can just plug this number right into the equation, just like that. Well, how are we going to get the yv? Okay, well, how did we get the y value of the vertex when it was in standard form? We just plugged 3 into wherever the x was and solved. So I'm going to have 3 squared minus 6 times 3 minus 9. Now my calculator dropped. Let's see. Let's see if I can get it. All right. So I'm going to do 3 squared minus 6 times 3 minus 9 equals negative 18. So my plus is going to have to change here to a minus 18. And did I get the same thing as before? X minus 3 squared, x minus 3 squared, minus 18, minus 18. I got the same problem. So you can do it either way, whichever way is easier for you. I prefer this method, just finding the vertex and then writing it in vertex form. That is my preferred method. But if you prefer completing the square, it doesn't matter how you get there as long as you're able to get there. There's lots of math problems where there's multiple ways to find the answer, and you just need to actually get the right answer, and no matter which way it is. All right, so here's some practice for you. Go ahead and pause the video and work it out on your own, and unpause it when you're ready to review the answers. All right, welcome back. We have here x plus 4 times x plus 4. And I'm going to do it my way, my preferred method for this one. I'll do FOIL maybe on the middle one here. All right, so x times x is x squared. X times 4 is 4x. That was a positive. 4 times x is 4x. And then 4 times 4 is 16. And so that gives me x squared. I'm adding these, x squared, 8x, and 16. And that checks out because x times 4 is 8 times, x times 4 is 4x times 2 is 8x. There you go. Now we need to plug this into our equation here. We've completed this much of it. So all we have to do to this equation, it looks like, is add 5 to the end. So instead of rewriting it, I'm just going to add 5 right here at the end. Okay, and then I want to combine my like terms, and I'm going to have f of x is x squared plus 8x, and then 16 plus 5 should be 21, but let's just double check. And it is. Remember, I always like you to use your calculator, especially on graded assignments. Calculators are just to check your work. I know you're smart enough to do it on your own, but use your calculator just to double check, because sometimes we can make simple errors and we don't want to have points off just for that. So this is our final answer. All right, so in this one, let's do, you see there's a negative here, but we cannot distribute that negative until we first do the square, because even though that negative doesn't look like we're multiplying anything, we're multiplying -1. Okay, times the x and times the 3. And so we have to do the exponent before we do the multiplication. So in this case, I'll do the FOIL first instead of the traditional way. So FOIL, and we have x plus 3 times x plus 3. This makes it a little easier when you FOIL to look at them written out. So first times first, x times x is x squared. Outside is x times 3, which is 3x. Inside is 3 times x, which is 3x. And last is 3 times 3, which is 9. Let's combine like terms and get 6x. So we got, let's put a negative on the outside. What we got was x squared. These two we used up to make 6x, which is a positive 6x. And then we have a positive 9 at the end. And let's tag on our -2, bring that, drop that right on down. And let's just double check this to make sure. X squared is x squared, 3 squared is 9, and then 3 times x is 3x times 2 is 6x. There you go. It worked. Now let's distribute this negative to everything inside the parentheses. So negative x squared minus 6x minus 9 minus 2. So essentially all you're doing is switching the signs of everything inside the parentheses. Now let's combine our like terms to get our final answer. -9 and -2, since they're the same sign, we combine, right? 9 plus 2 is 11, and you keep the sign, -11. So this is f of x is -x squared minus 6x minus 11. All right, moving on. Here, I'm just going to go straight to the shortcut. I'm going to do 2 times, what's x squared? Oh, it's x squared. And then our middle term is x times -2. -2x squared is, -2 times -2 is positive 4. X times x is x squared. So it's 4x plus 4x. And then -2 squared is plus 4. There you go. And then you have a -3 at the end. Now we can distribute 2x squared plus 8x plus 8 minus 3. Combine our like terms, and you're going to get f of x is 2x squared plus 8x. What's 8 minus 3? They have different signs, so we find the difference. 5, 6, 7, 8. So it's going to be the positive sign. The larger number gets the answer, so positive 5. And that is our final answer. Now we need to do the opposite, go from standard form to vertex form, okay? So I'm glad it has here one with a something other than a equals 1, so we can just make sure we understand what we're doing there, have some experience. But I want you to go ahead and pause this video, complete these on your own, and then unpause it when you're ready to go over the answers. All right, welcome back. So I'm going to complete these the way that I prefer, which is using -b over 2a to find my vertex of the x, which I happen to know is also h. And remember, my vertex form is a times x minus h plus k. A is already given to me in each one of these problems. So whatever A is in its vertex form, it's the same A in its standard form, okay? So I want to make sure that we have that clear. So whatever A is, we happen to see here that A is 1. So f of x is, I don't need to put anything down for 1 because it's just 1 with math. You know, when you multiply by 1, you get to drop that. So x minus, and I'm going to fill in the h, and then I'm going to plus, and here's where my k is going to go. So if a is 1 and b is -8. So let's look at my formula. The opposite of b, so positive 8, divided by 2 times a, 2 times 1. All right, that's 8 divided by 2, which is 4. So 4 is going to go right there. Now I'm going to plug 4 into my equation here. 4 squared minus 8 times 4 plus 15. Plug it into my calculator. Four squared minus 8 times 4 plus 15 equals -1. So I'm going to go back and change this to a -1 because I know k will be -1. And that's my final answer. Woo, that circle was horrible. Let's try that again. Oh, I think I might need to go a little slower. Let's try this again. I'll just put my calculator down and use both hands. All right, so here we have A is what? 1. B is -4. Did we use C in our formula at all in any way? Only when we were solving for H, right? To figure out what H was going to be, or the Y of the vertex. So that's the only time we use C. But in this case, C happens to be 0 because it's not there. There's nothing there, and we represent nothing with 0. So let's go ahead and begin to write our equation. F of x is, it's A, which I happen to know is 1. So I'm just going to drop that. X minus H squared plus K. All right, so now I'm going to do, no, I need the opposite of B. So if that's -4, the opposite of that is +4 over 2 times A. 2 times 1, 4 divided by 2 is 2. And we know that that is going to be our H. And then we're going to plug that into our equation. So 2 squared minus 4 times 2. 2 squared is 4 minus 8. This should be -4, but let me just double check that in the calculator. 2 squared minus 4 times 2 is -4. So again, I'm going to erase this and write -4. And so this is my final answer. All right, last problem here. We see that A is 2, B is 12, and C is 7. We don't really need to know that information. So I can go ahead and begin to fill out part of my answer here because I have an A. It's 2. Just going to go ahead and write that in. An X minus whatever H is squared plus whatever K is. So in order to find H, I'm going to take the opposite of B. B is 12. So the opposite of 12 is -12. And it's going to be divided by 2 times A. A is 2, so 2 times 2. So I've got -12 divided by 4, which is going to give me -3. Let's do that in the calculator just to be sure. -12 divided by parentheses 2 times 2, close parentheses, equals -3. So if this is -3, to put that in, I'm going to change my negative to a positive and write a 3 there. That's how you insert a -3, okay? Because you can't subtract a negative, it just changes to a positive. All right, now we're going to plug this in. So we're going to have 3 times 3 squared, -3 squared, excuse me, plus 12 times -3 plus 7. Plug that into my calculator. 3 parentheses, -3, close parentheses, squared, plus 12, open parentheses, -3, close parentheses, plus 7, enter. And I get -2 equals -2, which we know is K. This one was H. K is -2, so I need to switch my positive here to a -2. And that is my final answer. So I hope that you got all of those right. That's the end of our lesson for today, and I'll see you at the next lesson.